is my video for quadratic equation. In this video, I'm going to be writing the quadratic equation, not doing a sample quadratic problem. I will likely add a video in the future as a demonstration of how to do a problem using the quadratic equation. Right now, I just want to show you where the quadratic equation came from. This is not something that I expect you to do on a test or a quiz. This is just something that I think you might find interesting, and that I think it's important that you see that the quadratic equation isn't something mystical that was handed down to us by an omnipotent being, but is actually something rooted in mathematics and logic. Before I do the quadratic equation, I want to remind you of some facts about binomials. Here I'm squaring a binomial. I have x plus b squared. B is just any number. If I were to expand this, that would be the same as x plus b times x plus b. And I could use FOIL to expand it further to x squared plus 2bx plus b squared. And now this is important because I'm going to want to make polynomials look like this, because if I can make a polynomial look like this polynomial, I can rewrite it as x plus b squared. And we're going to see that that's going to be very helpful. Here I have what's called the general form of a polynomial. The general form of a quadratic. Any quadratic that looks like this, I'll be able to use the quadratic formula on. I can make any quadratic written in this way, where I have something times x squared plus something times x plus something without a variable. And you'll recall that I said on the previous slide that my goal was to make this look like x squared plus some number times x, plus 2 times some number times x, plus that same number squared. So I notice that I have nothing in front of x squared in my goal, so I'm going to start by dividing everything by a in order to get my x squared term cleared. So now I have x squared plus b over ax plus c over a, and this is going to be equal to 0. Because that's the definition for finding a root. I've said in class that you can only use the quadratic equation when you have a polynomial equal to 0. So this is all equal to 0. Now I notice I want 2 times a number here. So that means that b over ax needs to be 2 times a certain number. So I have x plus b over 2a squared. And now notice 2 times this term will give me that term. And I just use some logic to get there. But c over a does not equal b over 2a squared. So I'm going to need to fix that. And I'm going to do that, and this is going to sound a little weird, but I'm going to do that by subtracting c over a and then adding b over 2a squared. So now, right now, everything is still equal to 0. And that's what I need, because I need this polynomial equal to 0. But I can use my rules of algebra to add stuff to both sides of the equation. And so now at this step, it's not going to be equal to 0. It's going to be equal to, minus c over a. I'm also going to have to add b over 2a squared to both sides. Again, that's part of the rules of algebra. You can do the same thing to both sides. So b over 2a squared is the same as b squared over 4a squared. And now you might be looking at this a little skeptical and thinking, well, how can this possibly be the same as your starting polynomial, your starting quadratic? On the next page, I'll show you that these are actually the same before I go on to finish solving. So here I've rewritten what I ended up with on the last page, and I just want to prove to you that this is still the same, even though it looks very different. I'm going to start by foiling my binomial here. So this is x plus b over 2a times x plus b over 2a. And I'm going to use FOIL to get x squared plus b over 2ax plus b over 2ax plus b squared over 4a. I can combine these to be x squared plus b over 2a,
Hey, Mr. Scrill, sorry, I didn't.
b over ax plus b squared over 4a, and that's still equal to b squared over 4a squared minus c over a. I'm now going to use rules of algebra and subtract b squared over 4a squared from both sides. So these cancel out. At the same time, I'll add c over a to both sides. And so now I have x squared plus b over ax plus c over a equals 0. I'll multiply both sides by a, and I get ax squared plus bx plus c equals 0. And that was all just to prove to you that what I got was the same as our starting quadratic. Alright, so I'm back to this part. I just proved to you that this is equal to what we started with, even though it looks very different. I'm going to continue using rules of algebra and arithmetic. I'm going to start by adding these two fractions together. In order to do that, I need them to have the same base. So I'm going to multiply top and bottom by 4a so that they have the same denominator. And I get b squared minus 4ac all over 4a squared. And now hopefully you see that b squared minus 4ac and you go, oh my goodness, that is definitely part of the quadratic formula. I'm now going to take the square root of both sides. And so now I have x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 4a squared. Now that I have this, I remember that taking the square root of a fraction, that's the same as taking the square root of the top and the square root of the bottom. So I'm going to distribute that square root. I also know that the square root of 4a squared is 2a. So I'm just going to write that on the side. Square root of 4a squared equals 2a. So at this point I have x plus b over 2a equals plus or minus square root b squared minus 4ac all over 2a. I'll subtract b over 2a from both sides. I get x equals negative b over 2a plus or minus the square root b squared minus 4ac over 2a. But look, these fractions have the same denominator. That means I can add these two fractions together, and I get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Again, I just want to remind you, I don't expect you to be able to do this on your test. Looking at the time on this video, this is obviously something that takes a lot of time and a lot of forethought to go through. But what I hope this does do is prove to you that this formula really comes from logic and comes from the rules of algebra that you should already know. And that it's not just something that myself or another mathematician made up, but it really is grounded in the rules of algebra. Have a nice day.